Hello, and welcome again to FlippedHarber for Physics. In this video we're going to talk about scalars and vectors, a brief introduction to the two ideas, how they're similar and how they're very different. Now first of all, a scalar is a plain number, just a magnitude. Vectors, on the other hand, include a magnitude but also a direction. So if you see a number like 10 meters, that's what we refer to as a scalar. It only has magnitude. If you see a number like 10 meters north, that's a vector because it's got magnitude, the 10 meters, plus it's also got some direction information tacked on there. Some common examples of scalars, that is numbers that do not need a direction, are distance, speed, time, temperature, and many others. Common examples of vectors that we'll work with are displacement, velocity, and acceleration. Now you may have thought that a couple of these were the same thing, like speed and velocity. You probably use those in your everyday life interchangeably. We use the two different words to represent the two different ideas behind a scalar quantity and a vector quantity in physics. So speed would be something like 50 miles per hour. Velocity could be 50 miles per hour, but then we'd have to put some sort of direction on it, like 50 miles per hour north. Now, the way that we represent this direction is really going to depend on the problem. We can use words like up, down, left, right. We could use the cardinal directions of the compass, north, east, south, west, or any combination thereof. We could use words like toward something or away from something. And one very common way to represent vectors is with arrows. When we use arrows to represent vectors, the length of the arrow should represent the magnitude, that is the size of the number. And it should always be proportional. If I've got a couple vectors that are different magnitudes, the length of those arrows should actually be the appropriate lengths for those vectors. Now eventually we'll bring in some angles and actually do some trig with these vectors, but we'll save that for a later date. So you might be thinking, direction isn't that important. Well, in physics it really is, but it's really important in normal everyday life. Try telling someone how to get McDonald's without using a direction of any kind. By the way, pointing is using a direction. So is saying turn towards something or away from something. See, it just can't be done. You can't tell somebody how to get someplace without giving them a true vector, a direction in which to travel. So this direction is actually very, very important. Let's talk about some basic vector addition. Now this is really as simple as it gets. It's going to get much complicated later. I have vector A and vector B on the screen. They both point to the right. They have different magnitudes represented by the different lengths of the arrows. Notice the bars over the letter A and B. Those bars mean that it's a vector. So I want to add vector A and vector B. Well, the way I accomplish that is by just taking vector A and then taking the tail of vector B and setting it right at the tip of the arrowhead on vector A. A plus B is the total of the two vectors together. Pretty simple stuff. Let's try a little bit of vector subtraction. We want vector A minus vector B. Again, we place vector A down, and we're going to put a vector down for negative B, or we actually refer to that as opposite B. So we place the end of opposite B right where the tip of vector A ends. The difference is the subtraction of A minus B. We'll save some of the more complicated addition and subtraction for later. What you need to know for this class, you'll be working with vectors a lot through this entire year. You'll be learning how to do more complicated addition and subtraction later. Some of this is going to involve trigonometry. You really need to pay attention to the problem and what's being asked. When they ask you for a vector quantity, you need to give a direction. When they ask for a scalar quantity, do not give a direction. Now they're not going to tell you in every problem we're asking for a vector. they're going to be asking for a vector by using special words like velocity. That's a vector, so you need to remember to give a direction with that. If you screw it up, it will cost you some minor points on a test. Not too big of a deal as individual problems, but these minor points add up quickly, so you want to get it right from the very beginning. Okay, we're all done. I hope you enjoyed the lesson. I hope you learned a lot. I'll see you in class, and I'll see you online.